Let's take a look at another problem. The prolate cycloid is given by x is equal to 2t minus pi sine of t and y equals 2 minus pi cosine of t. The curve crosses itself at the point 0, 2. Find the equation of the tangent lines at this particular point. So if the graph crosses itself at the point 0, 2, we really would expect that there would be two tangent lines at that point, because the graph is going to be heading in two different directions. So let's try to figure out the slope of the tangent line, and we'll probably see how we can discern whether the graph will cross itself at a particular point. We know that it's going to happen at 0, 2. And so just for reference, we should find what the value of t is. They told us that it's at the two places in the graph. It shows at pi over 2 and negative pi over 2, but we need to be sure about that ourselves. So if I'm going to set x to equal 0, since I'm at the point 0, 2, I'm going to set x to equal 0, and this will be 2t minus pi sine of t is equal to 0. That will not be a very easy equation for us to solve. Hopefully, if I set y to equal 2, this will be an easier equation for us to deal with. And indeed it is. We find that we end up with the cosine of t is equal to 0, which is going to happen at t is equal to pi over 2 or negative pi over 2. You could have chosen 3 pi over 2 as well. I'm going to pick negative pi over 2 because it's consistent with the graph here. But know that this point is coterminal with 3 pi over 2. And so that would be an acceptable solution in this particular case as well. And if you plug 3 pi over 2 into the sine of t, you would still get the same thing. The thing is that the parametric equation, or the values of x and y, are never going to see particularly the value of t. They're only going to experience the effect of the t. So if the effect of the t, if the effect of negative pi over 2 is the same effect as 3 pi over 2, then x and y will be affected the same way. So we have our two values of t, and they're going to yield two different derivatives that we're going to find in just a moment. So in order for us to find this particular derivative, I need to find dy dx. And dy dx is going to equal dy dt. We're going to think operationally now, right? So we take the derivative of the y function with respect to t over dx dt. And so if I do dy dt, I'm going to end up with positive pi times the sine of t. And if I do dx dt, I will end up now with 2 minus pi the cosine of t. And the value of t that we're using is going to be one of the two. So if I were to do dy dx at 0, 2, and I'm going to use the point t is equal to pi over 2 in that space, then I will end up with the following. I will end up with pi times the sine of pi over 2, all divided by 2 minus pi times the cosine of pi over 2. And of course, the cosine of pi over 2 will be 0, and the sine of pi over 2 will be 1. And so we get pi over 2 as the slope of this line. How does that change for the other situation where I have dy dt, and I'm now evaluating that still at 0, 2, but this time we're going to take t at negative pi over 2. Well, this is going to end up being the following. Pi, the sine of negative pi over 2, all divided by 2 minus pi, the cosine of negative pi over 2, which of course is going to be 0 again. But the sine of negative pi over 2 or of 3 pi over 2 is going to be negative 1. And so we end up with negative pi over 2 as that particular slope. So our tangent lines will come to us in the form of, and I use For those of you who are not familiar with me, I use point slope form for my lines. I don't use y equals mx plus b. You can recover the y equals mx plus b by simplifying and solving for y. The point slope form is y minus y naught is equal to m times x minus x naught. Incidentally, this form is also consistent with the Taylor series, because certainly you could recognize it as this. And I hope that looks familiar to you. These are the first two terms of the Taylor series centered around x naught. So that gives you the graph of the tangent line. So really, you've been doing Taylor series since Calc 1, and you didn't even know it. So let's find this in point slope form. So this would be y minus 2 is going to equal pi over 2 times x minus 0. And if you really need it in y equals mx plus b form, you can get it by solving for y, and you end up with y equals mx plus b form. The same is true on the other side. You get y minus 2 is equal to negative pi over 2 times x minus 0. And if you want y equals mx plus b, this is y is equal to negative pi over 2x plus 2. And so indeed, we find that there are two different tangent lines at that particular point. What is most important for you just to be able to do with this, and what makes this a challenge, is being able to decide the information that you need. For example, when finding the slope of the tangent line, we know that we need the y and the x value. But when we're looking for dy dx, we don't need the x and the y value, we need the t value. So this is where this is going to become a little bit complex. When do you need x and when do you need y? Make sure that you understand when a particular value is required, and make sure that you understand what information is required. This goes back primarily to making sure that you understand what the equation is telling you. So the equation of the line, the equation of the tangent line is in terms of x and y, whereas our dy dx is not. It's in terms of t. And so we need to make sure that we understand the distinction and what is necessary for us to find the quantity that we're looking for.